word problems on inverse variation formula. So once again, do not try to guess the answers. Make an equation with meaningful variables and then solve that equation. So let's go ahead and start with the first one. The rate of vibration of a string under constant tension varies inversely with the length of the string. So the rate of vibration, I'm going to use R for the rate, varies inversely. So K as the constant of variation inversely means my next variable will go on the bottom in the denominator, and my next variable will be the length of the string. I'm going to go ahead and use the capital L for that. So that is the general formula. Then let's read the next sentence. If a string is 24 inches long, so L is 24, and it vibrates 128 times per second, so R is 128, L is 24. We're trying to solve for K. K equals 128 times 24. 3072. And once we've done that, we can rewrite the equation of variation with the K filled in. R equals 3072 divided by L. And then read the last sentence. What is the length of the string that vibrates 64 times per second? So R is 64, and we need to find out the length of the string. So in this equation, plug in 64 for R and solve for L. We have to multiply by the denominator, so 64 times L equals 3072. And then to find L, we'll just divide 3072 by 64. 48 inches. Now, number 2, the volume of gas held at a constant temperature varies inversely with the pressure of gas. So volume, V is my meaningful variable here, varies inversely, so K goes in the numerator, with the pressure of the gas, P goes in the denominator. If the volume of gas is 1200 cubic centimeters, so 1200 equals K divided by 200 millimeters of pressure, which means that K is 1200 times 200, 240,000. We can rewrite the generic equation with a K filled in 240,000 divided by P. And then the last question, what is the volume when the pressure is 300 millimeters of mercury? So volume is what we're calculating, and we're just plugging in 300 for P. And volume would be 800 cubic centimeters.